You will master SQL joins and join conditions in 4 minutes. Join conditions determine which rows from Table 1 should be matched with a row in Table 2, and consequently, which rows should not be matched. The first join condition is the on-join condition. The on condition takes a predicate, which is an expression that evaluates to true or false, and only matches a row from Table 1 with a row from Table 2 if that predicate is true. Let's set the predicate to b equals 5. For row 1 of Table 1 and row 1 of Table 2, b is equal to 5, so these rows should be matched. We get another match for row 1 of Table 1 and row 2 of Table 2. You'll notice that the second row of Table 1 does not match the first row of Table 2 or the second row of Table 2. Now let's grab all the matched rows. We just take the columns from the first table and the columns from the second table. For the first match, we take the data from the first table and then the data from the second table. Then, we follow that up with adding the data for the second match. Now we have our matched rows. We then pick a SQL join type to determine what to do with these rows. We run an inner join to simply take the matched rows. We take a left join to also add the rows in the left table that did not find a match. We can add in its values, and then for the attributes from Table 2, we just put in null values, since there is no match with Table 2 for data to put in there. The right join is the inverse of the left join. Hypothetically, let's assume the second row of Table 2 did not match a row in Table 1. Then we would insert in its values into the columns for Table 2, and then put null values for columns of Table 1. A full outer join adds unmatched rows from both tables to the matched rows. Let's say these two rows are unmatched, then we can go ahead and add them. For our next example, let's use a natural join condition. For a natural join condition, we join rows from the two tables based on the same named attributes, which is ID in this case. Since we are matching rows with the same ID value, we won't bother storing it twice and just merge it into one column. Then we add the unique columns for the first table and then again for the second table. We get two matches for first row of Table 1. We can add in the ID and then the name and finally the age for both of these matches. We get one match for the second row of Table 1. We can add in the ID and then the name and finally the age for the match. Let's say we do a natural join condition on a table of people and a table of what they eat. We need to match on ID and name. This doesn't really make sense, and we won't get matches since no person is named after a food. To remedy this, we use the using join condition, which takes a comma-separated subset of the same named attributes. We perform a natural join, but only on the attributes in the list. In this case, the name attributes will not be merged and be treated as separate attributes. The left anti-join says remove all the matched rows, and then just add in the unmatched rows from the left table. You can do the inverse for the right anti-join. A left semi-join is kind of like a filter. We keep all the rows in the left table that match at least one row in the right table using the natural join condition. We remove any rows that don't have a match. The inverse of this would be the right semi-join. The self-join is just a join we perform where the left table and the right table is the same table. An equi-join is a join based on equality. If we use on-join condition for age equals 7, then it is an equi-join. Doing is age greater than 7 is not an equi-join. The last type of join is the cross-join. The cross-join implicitly does the on-join condition with predicate of true, which means we match every possible row combination and we don't merge columns. Let's watch the join do its work. Hopefully, you learned SQL joins in 4 minutes. If you want to see the code or more detail, I'll add a link to a page about this stuff on SQLguild.com in the next couple weeks. Thank you for your time.